Anyway, good afternoon, everyone. So welcome to our seventh synchronous session. And our focus for this meeting will be on the problem set. So ang gagawin lang natin ngayon is titingnan lang natin lahat ng parts ng problem set. Say natin yung mga questions and siguro bigyan ko ng konting if hindi clear yung instructions. Ayun, siguro magbibigay ako ng additional context and ayun, depende rin sa question, baka makapagbigay ako ng hints or anything. Hopefully wala akong ma-reveal na sagot. Okay. So, ayun, as an overview lang siguro, the problem set is composed of 4 parts and yung kanilang deadlines ay pare-pareho lang on Wednesday, April 27 at 5 p.m. So, sinet namin siya at a Wednesday para hindi niya kasabay yung mga deadlines for the week na nasa Friday. So, as of now, we have a next week ay reading break and then we have a Lenten break. And after nun is meron pa kayong more than a week para ituloy yung problem set after the break. So, ang aming advice, huwag niyong gawin lahat ng problem set parts in one sitting kasi medyo mahaba sila. Hindi sila meant to be finished in one sitting. Siguro yung per part, pwede mong matapos in one sitting. So, ayun, mag-allot ka ng at least 4 days to do the problem set. So, hindi naman buong araw yun. I'm assuming mga 2 to 3 hours per part. And baka lang masira yung utak nyo if tinuloy-tuloy nyo yung kahit sabihin na natin kaya mo magawa lahat ng parts in 12 hours. Huwag mo naman dire-diretsuhin. So, ayan, let's start with the first part, which is focusing on the big O or yung ating worst case or ating time complexity ng ating functions. So, yung part 1.1, so yung part 1 ng part 1 is similar doon sa ating week 2 na exercise, yung sa big O problems. So, ganun din yung first part is merong given na functions and kailangan yung banggitin or pakita yung T of n, yung approximate nyo, approximation ng T of n, and then yung eventual big O na set or yung big O function kung saan kabilang yung T of n. And ayun, so pag naglagay ng ellipsis, so parang pseudocode kasi siya. So ang ibig sabihin lang nito is meron pang print 2, 3, 4, 5, 6, 7, 8, 9, 10 hanggang n-4 hanggang n-3. So even though walang nakalagay na loop, we can expect na madaming print statements yan na dumadami with respect to the input n. So ayun, ano yung time complexity nito? Then most of these are medyo self-explanatory. Dapat alam nyo na yung gagawin. And then another additional thing here, yung print function natin is can be assumed na laging O of 1 regardless of yung input sa print. So kahit mahaba yung input ng print function, O of 1 pa rin siya. So I think that would be useful for this function sa F4. Then itong si F6 may ellipsis ulit. So basically nested loops to hanggang n times. So if n is equal to 3, tatlong nested for loop. And if n is equal to 5, limang nested for loop. And then may kita nyo pa dito na yung niraran na function sa loob ay F3. So kailangan nyo rin yung time complexity ni F3 na tama. Kailangan tama to para matama nyo yung F6. Then si F7 ay isang recursive na function. Kinocall niya yung sarili niya. But si n, every time na i-call niya yung sarili niya is divided by 3. So, hopefully familiar na kayo kung paano makuha yung time, well, yung recurrence duration and then yung time complexity ng function na to. So, that is yung part 1. Oh, and then sa part 2 ng first part ng problem set is meron tayong black box na function. And yung black box na function over here, ang ginagawa niya is ine-extend niya yung input na list. Depende doon sa length ng list. So for example, yung input is 1, 2, and 7. Ang output niya is 1, 2, and 7 repeated 3 times. And yun, if yung input naman is 1, 2, 3, 4, ang output niya is 1, 2, 3, 4 na repeated 4 times. So ang first question here, or yung first requirement is you have to design a function that would perform this action, and kailangan mag-comment din kayo sa kanyang time complexity. So yun, since 2 points to, I think yung first point is if makadesign kayo ng function. Yung second point is pagkuha ng kanyang time complexity. Now, for example, meron kayong solution na O of n squared, and for sure na wala na kayong maisip na way para gawin siyang O of n, and then yung sagot sa second question is no, it cannot be done in less than O of n. Pero if makagawa kayo ng function na O of n, kailangan pala less than O of n, no? So, if O of n yung ginawa niyong function, hindi pala siya less than O of n. So, ang inahanap natin dito is log n or better. So, if makakagawa kayo ng constant time, edi mas mabilis, mas masaya, edi yes yung sagot dito sa second question. Pero nga, kayo kung hanggang saan yung magagawa. Pero for sure, if makadesign kayo ng function, meron na kayong significant number of points. Yung requirement, hindi siya requirement sa time complexity. It's more of a theoretical question na kaya po ba siyang i-improve further on. So yun yung si question or part A, question 2, section A. And letter B. So dalawa yung function dito. Yung output ng black box function natin is pinapasok natin sa tinatawag na BOGO sort na algorithm. So ang BOGO sort na algorithm is a type of sorting algorithm na ang ginagawa niya is sinashuffle niya yung input na list hanggang maging sorted yung kanyang laman. So parang for example, may deck of cards ka. Kung gusto mong isort yung cards in increasing value, isa-shuffle mo siya ng isa-shuffle hanggang masort siya. So parang medyo impossible or nearly impossible, but it is possible sa lahat ng combinations na ma-encounter mo yung na-shuffle, na sorted na list. So given that algorithm, ano yung worst case time complexity ng BOGO sort? Then, ayun, ano yung worst case time complexity? And of course, kailangan nyo ma-explain bakit. And then, if the input of your second function is the output of the first block box, is there a chance na yung BOGO sort natin hindi siya papasok doon sa loop? So, if may chance na hindi pumasok, ano yung chance na yon? If may chance na hindi pumasok, well, I guess, bakit hindi siya? Or bakit siya required pumasok dito sa while loop? So that is yung letter B. Letter C, replace natin si BOGO sort with bubble sort na ang time complexity niya is O of n squared. So, if may input tayo dito na merong size n, and then meron tayong output dito, eventually, ano yung time complexity para matapos yung first block box and then yung second block box? So, ayun na. Remember that we are analyzing the time complexity of yung buong nameless function version 2. So yung n natin is dependent so kung ano yung input natin na n dito is 10, tapos naging 100 yung nasa output, hindi naman necessarily ang O of n squared ang pagbabasihan niya yung 100. Ang pagbabasihan ng big O natin is yung input natin na 10. So, ayun. Ayun din naman, di porket nag-square yung number of output natin, yung time complexity is also squared. It could be faster, it could be slower. Depende doon sa implementation natin ng ating black box na function over here. So, hindi naman required na Python yung magawa niyong code. It can be in pseudocode or yung flowchart din, pwede rin. But we have to take note of our data structures. So if, ayun, lagay na rin kayong assumption, gumagamit ako ng dynamic list or gumagamit ako ng dynamic array or gumagamit ba ako ng linked list. So that is an assumption na kailangan nyo rin sabihin para ma-justify yung time complexity natin. Kasi we can say na nag-i-insert tayo doon sa ating list pero hindi tayo sure if yung pag-i-insert natin doon sa list ay constant yung running time. So, ayun. Then, finally, so merong black box plus bubble sort, may certain time complexity siya. And basically, yung question dito is kaya ba nating palitan yung nasa loob ng function na to para mag-improve yung time complexity niya. So, similar question to dun sa mga binigay noong week, so week 3, may binigay na function and nakakaisip ba kayo ng ibang implementation na same yung input and output na better yung time complexity. So the best yung best sagot dito is makapag-provide ng actual na algorithm, wag nyo lang siya i-describe, gawin nyo siya or pakita nyo siya. And makita nyo na rin kung ano yung bagong time complexity niya. So, ayun. Then, ayun, ang last part nung first part, no problems. So, part 1.3 is mastering the master theorem. So, you have to design a function that such that yung kanyang time complexity is O to the n to the 1.6. So yung 1.6 pwede yung 16 over 10, pwede yung hindi rin siya kailangan exactly 1.6. So pwede siyang 1.65, 1.68, gano'n. But yun, basta yung magiging resulting time complexity is O to the n to the 1.6. So, ang susundan natin ay basta makagawa kayo ng, I guess, kailangan mukha siyang divide and conquer na algorithm. Pwede rin naman siyang maging, so, ayun, basta magmukha siyang divide and conquer, siguro, gawa ka ng function, n, lagyan mo muna ng base case, if n, so, ito, parang meron tayong divide and conquer algorithm na yung A niya is 1, ang B niya is 2, and ayun, ano yung time complexity niya according sa master theorem. So parang kayo yung bahala maghanap ng combination ng A and B na magre-result sa n to the 1.6. So if dagdagan ko to, di ba? So tatlo na. So si A is 3, si B is 2. And ayun, so ano yung log 3 base 2, kumbaga, or pwede kong gawing 4. So, magiging 4 yung A, 2 yung B, magiging n squared yung term na yun. And, ayun. So, basically, kailangan nyo lang maghanap ng combination na hinahanap para doon. Or pwede rin naman kayong gumamit ng ibang paraan, kamukha nung sa binary functions, ay kamukha nung sa mga ibang recursive functions na hindi nagre-rely sa divide and conquer. Pero yun, parang kaya naman na siya with yung usual na divide and conquer. Then, ayun, yun yung for part A or yung letter A. For letter B is without changing yung A tsaka yung f of n, ano yung pwede natin gawin dun sa original na function such that yung kanyang time complexity maging n to the 2.6. So, ang suggestion dito, yung hint dito is use yung original function and use it within another function. So, kung ano meron tayong fun, alam nating O of n squared siya, pwede tayong gumawa ng another function. Fun year, ganun. Fun, and ko-call niya si function. So, yung magiging time complexity ni fun year is fun, n. Pero if i-try kong i-run si fun n 2 times, yung time complexity niya is yung twice ng time complexity ni fun. So, ayun. So, basically, with combinations of if, else, and loops, paano mo i-run si fun such that yung fun year is aabot siya ng O of n to the 2.6. So, ayun. Yun ang first part ng problem set on Big O. For those attending the live session, meron ba tayong mga questions regarding yung mga items na napakita? So if there are no questions for part 1, I think we can proceed to part 2. So for part 2, ang focus niya is on recursion and divide and conquer. Then we have a few general instructions that applies to all questions. So ayun nga, instructions, answer the following questions related to the presented code and show your complete solutions and state all assumptions made. And then when the worst case complexity is asked, provide yung ating tightest or smallest big O class na applicable. Excuse me. Then you are to cite any and all sources used, both offline, like reference books, textbooks, and online, like websites, and using any format na gusto nyo. Then for each page no answer sheet nyo or no submission nyo eventually, write your name, student number, and section handle. Then merong sample answer sheet sa dulo ng document. So after nung last question is merong yun, name, section, student number, section handle, and naka-rewrite yung mga questions dito and may space provided for your answers. So let's look at the actual questions. So problem 2.1, we have the following function na recursive, of course. It's some recursion. So ayun, merong function foo. Sa loob niya merong function na bar. And then si bar is meron siyang 4 na arguments, m, lx, ly, and n. And well, part nung question is yung pag-find out kung ano yung ginagawa ng ating function. Then, ayun, you are free to, this is written in Python and it works on Python pag nirun nyo. Tanggalin ko lang yung nandito sa dulong part. So, ito si foo. Kinopy-paste ko lang siya in my editor. And we can have a sample array na 4x4 in this case. And pwede mong i-run yung function with yung array as the input. So if i-print natin yung return value ni foo, you can see here na 9 yung sagot. Hopefully kita yung hindi siya masyado maliit. So let me just clear yung terminal. So pag ni-run ko yung function na foo, ang output niya is 9 actually. Or for example, magpalit tayo ng isang digit dito, 10. So 10 yung lilitaw. If mag-try akong palitan ko si 9 ng 0, the answer is also 10. If palitan ko si 8 ng 72, 72 yung naging result. If si 3 gawin kong 64 or 63 and 72 pa rin yung sagot. So ayun, medyo kayo naman na bahala kung magsabi kung ano yung ginagawa ng function. And ayun, I think mahanap naman dapat anong ginagawa niya. Then, ayun, parang yung quiz nyo lang no week 3, provide yung kanyang recurrence relation. So, hopefully by now, familiar na kayo sa recurrence relations. So, ang tinatanong na recurrence relation is for yung bar na function. So, yung bar ML. So, you can use yung M, CLX, CLY, or CN doon sa paggawa ng inyong recurrence relation. Pero I think medyo hint na rin yung nasa answer key or nasa answer sheet is T of N. So you will probably use yung N dun sa ating input. Then, ayun, after ng recurrence relation, simplify to get the worst case time complexity. And then, you are to assume na constant naman lahat ng non-recursive call dito. So constant yung access time, constant yung max function. So yung max function built-in siya, it gets the maximum of yung kanyang contents. So actually, generic naman siya sa Python. When you run Python 3, when you call the max function, get the max of 1, 2, 3, and 4 or 5. Of 1 is 5. If kunin niyo yung max ni 10, 2, 3, 5 is 10. So since laging 4 yung input ng max function, we can assume that this is a constant operation. Then ayun, so yung letter C is yung time complexity, letter D yung kanyang space complexity. You should be familiar with how that works by now. And the letter E is currently si foo. Divide and conquer algorithm siya with 4 partitions. So how would increasing the number of partitions affect the runtime and yung space na needed? And conversely, what will happen if decrease ko yung number of partitions? So hindi nyo naman kailangan i-implement yung increased partition version or yung decreased partition version. Medyo theoretical lang ano yung mangyayari if i-try kong i-increase yung number of partitions while maintaining yung functionality, of course. So ano yung mako-comment nyo on the running time and yung space required by the function. Then lastly, for letter F, is it possible to have another algorithm that is functionally the same as foo but avoids recursion? So I think yun naman yung gustong ginagawa ng most. If merong binigay na recursive na solution, maghahanap pa rin ng solution na iterative. So, ayan, hanap kayo ng equivalent na function na iterative siya instead of recursive. And, ayan, provide it dun sa, I think pwede nyo naman screenshot yung code nyo and paste nyo as an image dun sa PDF if meron kayong magandang PDF editor. Pwede nyo naman siyang i-attach as a different attachment. Pero, ayun, the best would be if kaya nyo siyang ilagay dito. And hindi naman siya ganun kahaba, I think. Well, at least yung solution na naisip ko. Then ayun, hint na rin yun. If possible siya, provide yung other algorithm and comment whether it is better or worse than the original function. So yung better or worse can be in different metrics such as yung time complexity, space complexity, actual na time, running time, actual na space consumption, ease of coding, or mas madaling intindihan or not. And ayun, if hindi siya possible na gawing iterative or non-recursive, briefly explain why. So I guess with the way of how I am explaining yung question, baka medyo hint na kung yes or no yung sagot dito sa original na question. So yun yung problem 2.1. Si problem 2.2, medyo similar lang din pero we have a different function. So in problem 2.2, we have baz na recursive din. If yung length ng input is less than 1, it returns an empty, it returns a list with an empty string. Otherwise, meron siyang temporarity and meron siyang nested na for loop. And I guess yung challenge dito is yung isang for loop, ang kanyang argument or yung list na ina-iteratean niya is yung result ng recursive call doon sa function. So, I guess makakatulong sa atin kung intindihin kung ano yung nangyayari dito is to answer yung first question. Ano yung ginagawa nga ng function? And I find it useful if kaya nyo siyang i-copy-paste sa inyong editor over here. And then try nyo siyang i-run with different inputs. So, open natin siya in interactive mode. So, pwede natin i-call si baz ABC. And then we get the following output. And if we try another input, A, B, C, D, ito yung output niya. If pwede ka rin mag-input ng 1, 2, 3 or 3, 2, 1. So, hopefully nakikita nyo kung ano yung ginagawa ng function. Kahit na hindi nyo nakikita yung source code, you should have an idea kung ano yung output niya. So, A, B, C, D, E, F. So, imagine pag mahaba yung input natin, mahaba din yung output by a significant amount. So, ayan. That should, if na-answer niyo yung part, letter A, yung letter B natin should be easier, which is finding the recurrence relation baz. So, ayun, pwede nyo siyang isa-isahin. Pwede nyo ihiwalay dito. Let's say we have a temporary na list B equal dun sa baz na function, and ano yung running time niya, nasa loob siya ng for loop. So, kailangan nyo siyang i-multiply. And then, kailangan familiar din kayo with the contents niya or ano yung mga resulting list pag kinol mo siya. And yun yung magiging number of iterations ng innermost na function. And then, we have an assumption here na yung append natin is constant yung running time. So, yung append and yung concatenation, constant time lang siya in this case. Which may or may not be actually true, pero yun yung assumption natin. So, ayun, meron lang tayong for loop. So ako, di ba, gusto ko mag-start sa innermost. So ano yung time complexity nito? Multiply mo siya sa number of times na magra-run siya, which depends on the number of elements ni baz. And if alam mo na yung number of elements ni baz, multiply mo lang siya sa time complexity nito. And then, nasa loob pa siya ng for loop. So kailangan din natin alamin yung time complexity nung pag-run nitong function na to. And yun, mag-multiply and mag-add. So kayo na, alam nyo na dapat kung alin yung i-multiply or i-add doon. Then next is letter C. If A has length n, what is the worst case time complexity ni Baz? So basically, simplify yung recurrence relation ni letter B. Ayun, siguro if meron kayong naiisip na pwedeng sagot kay letter B, and if hindi kayo sure, pwede nyo naman i-verify with me. Although ang gagawin ko lang is tatanungin ko paano nyo nakuha yun. And if meron akong nakitang mali doon sa explanation nyo, ipo-point out ko lang yun. Pero syempre, hindi ko sasabihin if tama or mali yung sagot. And then letter C. Ayan. Yun nga, ano yung time complexity niya. So, tinanggal ko na actually yung space complexity. Originally, may space complexity pa to. Pero medyo mahaba kasi siya. Note lang na yung n plus 1 factorial, n factorial, and n minus 1 factorial all differ by a factor of approximately n. So, parang pag kinompare natin si n plus 1 factorial kay n factorial at n minus 1 factorial, para tayong nagko-compare ng n cube, n squared, at n. So, if ever may factorial yung sagot nyo, be sure to include or not include yung mga plus 1 and yung mga negative 1 kasi nagmamatter siya in terms of time complexity. So yan, medyo hint na rin to na ano yung ina-expect nating sagot sa letter B. Meron siyang some factorials involved. And then after nun is may modification tayo to Baz, or hindi mo siya modification since same pa rin to. Meron ng additional at the end for the Bazab function. So, ayun, without looking at this, pwede nyo na, or without analyzing it directly, pwede nyo namang ilagay lang sa ating source code. So, Bazab over here. Actually, pwede ko na, alam ko, pwede ko na siya i-call dito. So, pag tinry ko siya with ABC, ang result natin dito is actually an empty set. Pero, siguro hint nyo dito, yung original is Baz, ngayon naging Bazab. So, what if gawin kong ABC, CBA? So, yung output ko will be these strings. Then, what if maglagay ako ng shorter na string, ABA, like ganun. What if dagdagan ko yung A? So, wala. What if lagay ko race car? So, ano yung mga nagiging result ni Bazab na function. So, note lang na siguro a couple of hints. Kung ano yung length ng input, yun din yung mga length ng mga nasa store. And then, pwede mo tingnan lahat ng inputs dito. Ano yung pare-pareho sa kanila or alin yung symmetric sa kanila. But ayun, you should have an idea of what the function does or ano yung result ng pag-call ng function. Then, ayun, the next question is it possible to have another algorithm? It's functionally the same but has a better time complexity. Now, by the way it is worded, siguro naman baka, not sure if option pa rin yung sagot na no. Pero if yes, provide a faster or provide the fastest solution that you can think of and justify yung kanyang time complexity. And pwede nyo gamitin yung time complexity na nakuha nyo na dito kay Baz. So yung Baz na to, alam mo na yung time complexity niya. So, pwedeng one approach is to maybe pwede mong gawing iba yung input mo. Excuse me. Instead of yung buong A, pwedeng subset lang ni A yung ilagay mo or not. And ayun, I think yun lang naman yung possible or isa sa mga approaches. So, meron different approaches doon. Pwedeng hindi mo galawin si Baz A para yung time complexity niya hindi na magbabago, hindi ka na mag-recompute. So, parang palitan mo na lang yung time complexity nito, di ba? Para maging mas mabilis siya. Pero yun lang yung aking mga hints for this part of the problem set. Meron na provided na answer sheet. Na-proofread ko naman na to, pero there might be cases na iba yung tanong na nalagay dito kaysa dun sa tanong na nakalagay dito sa original part. So, ang susundan nyo is kung ano man yung nandito sa initial part. So, answer sheet. And pwede nyo hindi gamitin yung answer sheet if meron kayong sariling format na gustong sundan. Or siguro if gusto nyo ng Word or editable version nito, yung hindi PDF, siguro upload ko sa Discord natin. Or maybe upload ko rin sa Uvle para for the benefit of everyone. Then, so yun yung for problems at part 2. Merong any questions with the items dito kay part 2? If wala, I think we can move on to part 3. So part 3 is on linear data structures. So ito, given a list of X objects, you want to create a program that performs the following operations. So function 1, ang ginagawa ni function 1, kinukuha niya yung first and yung last object, and then ilalagay niya pareho doon sa start of the list. Si function 2, similar, get the first and last, pero lalagay niya sa dulo. So, we want to implement yung functions, and ang basically yung questions dito is when we have a stack, and if we are using a stack, paano mo magagawa si function 1, and ano yung time complexity ng implementation na yun. So actually, gumawa ako ng example dito gamit yung queue. So ginamit ko yung queue class na provided nung week 5. So meron akong queue, yung laman niya is A, B, C, D, and E. So if i-print ko yung queue initially, and then i-run yung function 1 and then print ulit si queue. Ano yung magiging runtime niya. So yung initial na queue is A, B, C, D, and E. And kinuha ko yung first and yung last and kinabit ko siya sa umpisa. So that is yung function ni or ginagawa ni function 1. Then ayun, so yung implementation over here, well, there are several ways to implement it, pero the way I did it is basically meron akong temporary na queue at saka yung bagong queue. Yung temporary na queue, doon ko hahanapin yung last element. So ito yung ginagawa niya. Find the last element. So ito yung first element, queue.front. Yung last element is yung queuetemp.front, and then transfer all the other elements ng queue. So yun yung nangyari dito. Then looking at it, ito, time complexity nito will be O of n, di ba? And then this is another O of n na operation, assuming na si NQ at saka DQ ay constant na operations. So dalawang O of n ang time complexity niya for function 1 is O of n. So wala naman Q dito, kaya yun yung ginawan ko ng example. So ayan, if you want to implement yung function 2 using a stack, paano kaya yon? Or using a linked list, using a doubly linked list, using an array or a deck. So, hindi nyo naman kailangan i-provide yung actual na implementation. Although, kung wari, pag sinabi kong O of n, kailangan may explanation ka. For example, sa stack or sa queue, in order to access yung last element ng queue, we have to traverse the whole queue. So, that would be O of n. So, eventually, yung pagbuo ng function would be an O of n operation. Or if gusto kong insert siya in the middle of the queue, well, hindi siya possible kasi queue siya. So, kailangan kong bumuo ng bagong queue. Parang ganun. You can explain your implementation, pero ikaw, if kaya nyo naman ilagay yung implementation, that will be very helpful, lalo na sa amin, para hindi namin hinuhulaan yung sinasabi nyo sa code. So, ayan, basically, gawin nyo lang ito. So, meron akong function 1 for the queue. Gawin nyo siya for function 2 for the stack, or function 1 with a linked list, singly or doubly. And then, pwede ring array, pwede ring deck. So, array, ito yung regular na Python na list or yung dynamic array. So, ito yung number 4. And be aware or be cognizant or pansinin nyo. If gumamit kayo ng linked list, yung mga insert, delete, and access operations nyo, hindi sila laging constant. So, that would matter a lot in determining yung big O complexities ng mga to. And then number 6, what is the best linear data structure for implementing this program? So yung program is function 1 and function 2 combined. So given yung time complexities na nakuha nyo for function 1 and function 2, which do you think is yung best to use for this this question, for this program? And for example, meron kayong tie, justify nyo rin kung bakit nyo pipiliin yung isa over the other. Or if tie talaga siya, banggitin nyo pareho. And pwede nyo naman sabihin, mas pipiliin ko, for example, mas pipiliin ko yung stacks if ganito yung situation, mas pipiliin ko yung queue if ganito yung situation. But overall, pareho silang the best. Pero, ayun. So, yun, parang sample question, sample answer lang yun. Pero not really the answer. Then for questions 7 and 8 and 9, ayan, consider na yung time complexity ni 1 is O of M, time complexity ni function 2 is O of N. So what is the time complexity of the program if we repeatedly call function 1 and function 2 consecutively until we find the original order of the list of objects? So, pwede nyo tingnan when we call yung function 1 over and over again. So, gawin natin interactive. So, si Q, ito na yung, or, yan na yung naman niya. If si Q, i-modify natin ulit, pasok natin ulit kay function 1. You can see na ayan, yung last element na punta sa umpisa together with the first element. So, pwede ko siyang ulit-ulitin a certain number of times. And then, eventually, babalik tayo sa dati. Actually, lumapas ako. So, ayan. Basically, yung tanong lang nito, how many times mo siyang ulitin para makuha yung original na list. So, yun yung function 1 and function 2. Number 8, we just call function 2. So, ito is using both function 1 and function 2. Yung sa example ko is just function 1. So, si number 7 yata, i-alternate mo or not. Pero ito, si function 1, function 2, ito is function 2 lang. And then si number 9, if meron tayong list na descending order and gusto nating isort in ascending order, ano yung time complexity niya. So, the best explanation dito, if makakapag-provide ka ng pseudocode or na algorithm using function 1 and function 2 na magre-result doon sa reverse sorted na list. So, and then justify yung kanyang time complexity. And then ayan, may bonus question lang over here at the end. Kumusta yung semester? Since madali lang yung linear data structures, siya yung may extra question. Ayun, so medyo feedback since lalo na if makasubmit kayo earlier, pwede namin siya ma-incorporate during the reading break while we are reassessing yung ating course. And ayun, pwede nyo naman sabihin directly. Hindi nyo naman kailangan hintayin yung submission para sabihin sa amin yung feedback nyo for the course. Lalo na yung nasa reading break na tayo. So ayun, so that is for part 3. Wala namang questions, di ba? Kaya tayo move on sa part 4. And baka matapos tayo in under 1 hour. Okay. Part 4 is on nonlinear data structures. So meron tayong 2 figures dito sa umpisa. So this is a tree. Not yet sure if anong klaseng tree siya, pero mukhang binary tree siya. And then we have another tree here na binary din. Hanggang dalawa lang yung mga nodes. Then for the problem 4.1, kailangan yung makuha yung traversal ng ating nodes using DFS or BFS. So I'm not sure if mentioned siya sa videos, pero dun sa lecture class natin last Tuesday, hindi ko yata nabanggit ano yung DFS tsaka yung BFS. Ang DFS ay depth first search, and ito yung pre-order, post-order, tsaka in-order. So lahat to ay depth first search. So bakit siya depth first search is kasi nauuna tayo sa mga leaf nodes. Pag umabot tayo sa mga leaf nodes, tsaka siya bumabalik, di ba? Sa pre-order, lahat ng nadadaanan is napiprint muna natin. And then, eventually, yung huling mapiprint sa kanya is yung last node na ma-visit. Pag post-order, ayun. Parang nagtatraverse tayo palalim ng palalim dito, di ba? Or yun, pwede nyo na isipin na gano'n. Di ba, if babasahin natin si pre-order, pupunta muna siya sa left. And then si left, ang una niyang gagawin is pupunta ulit sa left. So basically, punta tayo sa dulo ng left, and then punta tayo sa dulo ng right. Yun yung depth first search kasi hanapin muna natin yung dulo. So yung DFS pre-order, DFS post-order for figure 1 is just ito, yung pre-order na to, tsaka yung post-order na ito. Then yung tinatawag na BFS or is yung breadth. Hindi ko masabi na maayos. Breadth first search. In contrast sa depth first search, nahanapin muna natin yung dulo, yung breadth first search is kung sino muna yung magkaka-level. So ang breadth first search natin for this tree, we always start from the topmost level from left to right. So yung breadth first search nito is F, and then BG, and then ADI, and then CEF. So kung yung depth first search natin, palalim muna siya ng palalim, ang breadth first search natin is palawak muna siya ng palawak. Palawak ng palawak. So, ayan, so basically daanan nyo lahat ng level 1, daanan nyo lahat ng level 2, daanan nyo lahat ng level 3, lahat ng level 0, level 1, level 2, level 3. So ito yung ating BFS. Mas relevant kasi yung depth at saka yung breadth pagdating natin sa graphs, pero ginagamit din siya sa trees. And I think baka ginamit din naman yung mga terms na to during the lecture videos. So, ayan. Ayan, so implement lang yung traversals. So siguro since wala yung DFS in order, we can do it for this data structure. So yung in order, di ba? Lalagay ko ng dot sa baba. And then palitan ko ng kulay. So starting from the left, no root node is magta-travel tayo. So una natin nadaanan si 1. And then si 15. And then si 36. And then ang susunod natin is 52. And so on and so forth. Medyo nakakamata. Pero ayun, so yun yung ito yung DFS na in order. I guess yung next project kong bibilin after the mic is a writing tablet. So yun yung in order. So yung nahanap yung pre-order and the post-order may figure 1. And then for figure 2 then, gawin nyo yung DFS and then yung BFS. And then problem 4.2. Ito si figure 1. Binary tree siya sa ngayon. I think BST pa nga yata siya. And convert nyo lang siya to a max heap. Excuse me. Alam nyo naman yung difference ng. So yung binary tree natin is lahat ng nasa left mas maliit, lahat ng nasa right mas malaki. For the heap structure, lahat ng malaki nasa taas, lahat ng maliit nasa baba. So there are several, there are several, pwede nating pagpalit yung 35 at 23 dito and that will be perfectly fine. So madaming possible answers dito. So ang basta kailangan nyo lang ma-maintain yung property na lahat ng elements sa taas mas malaki, lahat ng elements sa baba mas maliit. And that only applies dun sa mga ancestors and descendants. Like here, si number 4 is mas maliit siya kay 21 pero nasa the same level si 4. But this is valid kasi yung ancestor lang naman ni 4 is 23 and 45 and pareho silang mas malaki. Si 4, hindi naman siya descendant ni 21, so it doesn't matter. Naka-level na siya. So yun yung kailangan mong gawin. Problem 4.2.1. And then for 4.2.2, si figure 2, gawin nyo siyang minimum heap. So yung maximum heap is yung largest element yung nasa taas. Pag minimum heap, lowest element yung nasa taas. And then we assign our values by the string length. So ibig sabihin, yung pinakamaikling words nasa taas, pinakamahabang words nasa baba. If we have a tie, we break them lexicographically. So anong ibig sabihin lang nun? That is yung alphabetical na sanay tayo. So for example, si no at saka si B, pareho silang 2 letters. Mas mauuna natin ilalagay dapat si B kay no kasi nauuna siya alphabetically. So yun lang yung lexicographical na nakalagay dyan. Then problem 4.3 is we have heaps. So for question 1 or number 1 dito kay 4.3, draw the initial tree structure after the insertion ng 99. So this is yung initial na insertion. So saan mo siya ilalagay? So dito ko ba ilalagay si 99? Parang ganyan ba siya? Or dito ko ba ilalagay si 99? So saan ko ba siya dapat ilalagay? So yun yung sa letter A. And then letter B is show the process of insertion. So pwede nyo i-describe yung process or pwede nyo mag-draw ng multiple trees. So I think an example nito is yung nasa slides. So kuwari ito, nag-add tayo ng 42. So ito yung sagot natin for the first question. And then for the next question, papakita natin si 42, umaakyat siya ng umaakyat. So we can draw the trees multiple number of times, pero pwede mo sabihin si 42 makikipag-swap siya kay 27 and then makikipag-swap siya kay 35. Parang pwede na siguro. At least for me, pwede na yung ganong sagot. So hindi nyo naman kailangan i-draw yung heap natin every time. So yung letter B. And then letter C is draw the final tree structure. So, ito na yun. Tapos na yung ating pag-modify ng tree and pag-maintain ng heap property. So, kailangan nyo lang pakita itong final na tree dito sa letter C. And so, yun yung sa insertion and then sa deletion. Draw the initial tree structure after deletion. Parang nasa slides. So, pag dinelete natin si 45, ano yung itsura niya? So, ganun. And then show the process of deletion. Parang similar dito. Pero instead of insertion, deletion. And then draw the final tree structure. Next, we have problem 4.4, which is on priority queues. Yung priority natin dito is given by the lambda function x, which is gets the ordinal equivalent ng x dot lower, index 0 minus 97. So pwede nyo naman paglaruan yan sa Python. Pag ginamit mo yung, if hindi nyo pa na-try, if ginamit nyo yung ORD function, tapos meron kang character dyan, is maka-convert siya to a number or yung kanyang ASCII equivalent if I'm not mistaken. So if letter B to, may 98, if mag-minus 97 tayo, like yung nakalagay dito, actually, si A yata ay 0 and then si Z is 25. So yun, si X siya yung input. So, for example, Hagya. You lower 0. So we get 7. So, and basically, intindihin nyo lang anong ginagawa nito and describe nyo anong ginagawa niya for number 1. And then number 2 is show the output after heapifying the list. So in list form as well. So, not sure if may example dito no. Ayun sa slides ko yata yung meron. Siguro dapat in-upload ko rin to. No? Convert ko na rin to PDF. Ayan. So, ito yung heap natin and ito yung array form niya. So, di ba, index 1 to, index 2, index 3, 4, 5, 6. So, ganyan yung magiging itsura niya. So, ang inahanap dito sa problem 4.4, nung naka-list form, is i-heapify nyo to, itong list na to. And then, so expectation is mukha siyang array, but naka-heapify na siya. So again, yung heap natin can have several different or parang same version. Pwede mo siyang i-heapify in different number of ways. Either mag-heapify ka from the top, heapify ka from the bottom. So pwede magkakaiba yung mga sagot, pero pare-parehong tama as long as ma-preserve natin yung property ng heap na lahat ng nasa taas mas malaki, lahat nasa baba mas maliit. And then, so yung problem 4.4. Similarly, si problem 5, which is hash tables, it uses the same list over here. Hindi yata nabanggit. I think nasa forum yun. Yung 4.5, well, actually, problem 5, 4.5. Gagamitin niya yung same list over here. And then yung hash function natin is we get the sum nito. So, di ko siya pwedeng describe further kasi yun yung question. Okay. So, describe nyo anong ginagawa nito. Yung lambda function is basically yun nga, single line siya na function. Yung input is x. So, yung x dito, palitan nyo lang with the input. For example, yung Hagya, Sophia. And then, ayun, if C is upper, yun. Pwede nyo naman itong ilagay sa Python interpreter para makita ano yung ginagawa niya. And yun, we can explain yung hash function using that. And then generate the map using external chaining. So, ano yung expected na itsura niyan is, ayan, di ba yung hash natin, meron siyang indices. So, index 0, index 1, index 2, index 3, up to ilang index ba yung ating hash function. So, given yung hash function, dapat malaman nyo kung ilang indices yung ine-expect natin. And then, ayun, gawa lang kayo ng chain. So, pwedeng nandito si off. So, isusulat ko lang yung maliit para madaling bilis. Dito si Giza. So, hindi ito yung sagot by any means, pero yung na-expect nating nasagot is something that looks like this. Nakuha ba? Yes. Yes. Okay, so yun na yung problem set part 4. And actually, nadaanan na natin lahat ng parts ng problem set. And almost exactly 1 hour lang naman ang nakalipas. So, ayun, that actually ends our session for today. Wala na akong iba pang sasabihin, kundi good luck sa problem set. And I hope that the following weeks will be productive or meaningful. So again, next week is the reading break. Next week is the Lenten break. So the next time na mag-meet tayo ulit will be in 3 weeks, probably April 19 or 21. So again, yung ating problem set, ang deadline niya is on April 27. And if there are no more questions, that ends our session. Okay, may isa pang may question. Sige lang.
For the following week, sir, when are you available for consultation?
Okay, so for the reading break, I can follow yung usual na time natin for our class na Tuesday, Thursday na 1 to since magkasunod yung THWX3 at saka THYZ, so buo na yon from 1 to 6:30 yata. And yung MWF ko rin naman, since consultation hours ko yon, pwede rin naman. So, medyo relatively free next week ako. Baka lang ma-champion nyo akong gumagawa ng thesis. Pag na-champion nyo akong gumagawa ng thesis, baka di pa kayo ma-reply. Pero, usually, or most of the time, available naman ako. If gusto nyo mag-schedule ng one-on-one na consultations, ayun, mag-send lang kayo ng email with your preferred na schedule. And if hindi ako pwede, mag-ask ako. Or yan, pwede kayo magbigay ng 1, 2, or 3 possible schedules. Pipili na lang ako o kung alin yung pinaka-available ako. And you're free to message me anytime during the reading break. For the Lenten break naman, yung family namin gets busy ng Thursday, Friday, and Saturday. So, baka Easter Sunday evening, doon kung pala kayo mare-replyan talaga. Pero if meron kayong mga short questions, short clarifications, okay lang naman. Pero yun, ang aking preference ay during the Holy Week, baka ma-entertain ko lang kayo on Monday, Tuesday, and Wednesday. So, ayun. Lagay ko rin naman yun as an announcement next week sa ating Discord. So, ayun. May questions pa? Well, deadlines pa rin ng week 6 activities this Friday unless meron kayong excuse. Pero, ayun. So, hopefully, kung reading break man, if gusto nyo man mag-work, problem set na lang. Problem set lang muna for EEE 121. So, ayun, thank you very much for attending today's session. Hopefully, sa afternoon session, nandun yung 10 pang sumagot sa poll na gustong mag-meet today. Pero yan, thank you very much for attending and I'll see you next week.
Thank you, sir.
Thank you. Bye-bye.